So to begin designing the PCB, I started off with laying out my circuit. So this is the ATtiny 85, a 10K resistor, and then the photocell, along with the micro USB port, and then the 4 pads on the back, along with the ground pad, each going to the respective pin. And then I have an LED control pin, which is pin 1, for port B1, which has the 4 WS2812B LEDs attached to it, and with 5 volts going to each of them, ground going to each of them, and then the serial data line. So this is the PCB outline. I have a 3mm hole for mounting, and then each of the 4 LEDs surround the ATtiny 85 that's in the middle, and then I have on the micro USB header, and then the photocell. And then below, on the bottom layer, in blue, we have the 5 pads and then any other traces that go underneath. What I was then able to do is go to Fusion 360 and then push it to Fusion to then design any CAD model around that. I have imported from Eagle the board along with the outline and each of the pads and then the mounting hole, and I was able to design a base that goes around that. So here's a little point for the screw to attach, and here, and then a top plate that goes on top, and then each of the LEDs can shine through here, and then the photocell can sit on top. I uploaded my .brd or board file from Eagle, and here it is. Here's the board preview. So we have the top layer and then the bottom layer. Here is the new microscope that I got from banggood.com. So as you can see, it's mainly used for electronic components, and it features a 3.5-inch LCD screen and pretty good zoom, up to about 600 times. So let's go ahead and just turn it on. And it is battery powered. And as you can see, that's what it looks like zoomed in. So now let's go ahead and put something on there, like this little board. And that's what it looks like on there. It has nice, really bright LEDs and can record or take pictures. So we can zoom out, and then you can reposition it, and then use this knob to then adjust it. So let's turn it back this way and refocus it. There we go. And then I'll change the mode over. So now we can take a picture with it. So let's go ahead and do that. So take a picture. So just took a picture of it. So let's go ahead and start soldering up a board. Now I have this component right here. So 103 just means 10 times 10 to the third, or a 10,000 ohm resistor. So this is a 0805, which means that it is 0.8 by 0.5 millimeters. And that's the little SMD resistor. So now I'll just turn on the soldering iron. In the meantime, I will demonstrate an RGB LED. So this, zoom out here a little bit. WS2812B LED, and as you can see, it has 3 sections on there, and each one of those is red, green, and blue, and then it has a little controller on there which determines what color it lights up based on the information it gets. And these run off of 5 volts, and it is just serial data in, data out, 24-bit color. And here is the microcontroller that I'll be using, E5 microcontroller. So it is pretty much an Arduino Uno, but half of a lot of stuff. So it has half of the SRAM and half of the flash storage that an Arduino Uno has. And it features 6 pins, and then ground and 5 volts. And lastly here, we have a little connector. It says micro USB. As you can see, very, very fine pitch in each of the pins. And then if we just turn it, this, you can see the connector on the inside. That's where the cable plugs into. Just like that. So, let's go ahead and get started. You'll get a little bit of masking tape here. And just lay it across. So our board can stick to it, just like that. Then I will move the microscope over. See here. Position it right here. Right there. Perfect. I have nice solder right here. And let's go ahead and get out the soldering iron. Clean off the tip a little bit. And let's go ahead and get started. So first, we have our soldering iron. We will apply a little bit of solder to that pad. Just like that. And then with our really fine tweezers, just go like this. And then just kind of move it over like that. Let it cool off just a tiny bit. Wipe off the iron. And come over on this side. Heat it up. Try to at least. And then adhere that resistor to the pad. Just like that. And we'll just wipe up this excess solder. Perfect. Here as well. So it's going to put down a little bit of solder. Just hit it a bit. Perfect. And then go ahead and hit this with a bit of solder. This with a bit of solder. And then get tweezers. And go ahead and maneuver this component. And we have to line up the pads with the pins. Let's move back over. Nope. Nope. There we go, something like that. And then we'll go ahead and get soldering iron right back here. And then press down on it. Perfect. That's very, very fine pitch soldering, but it's on there now. So let's go ahead and start soldering on the LEDs. So now I have the fine pitch pins on there. Let's go ahead and start with the LEDs. So as you can see, they each have a little triangle right here on the top, which tells you the orientation. So on here, there's a little triangle on the top as well, right there. So I'll take LED. Just like that. Then come over on this next side, and then let a little bit of solder. Just like that. And again on this side. Perfect. And that is one LED. It's been soldered on. So it moved a little bit, but it's fine. It's not too bad. Right here you can see the pins here have lifted off. So we'll squish those down. Those last two pins on either side, and go and solder those. Just apply a little heat, a little more solder. Just like that. Here, you can see that although the connection isn't as good, it's still somewhat there. You can see, especially with that last one, that's on there fine. So now we got this. Let's go ahead and put down a couple blobs there. Our next LED. Barely position it, so. Top. Just a little blob there. Then make sure to line up the triangle. That's at the top. Like that. And then apply a little bit of solder to this pad. So, and then a bit of solder to this pad. Then you always want to do surface mount components first, and then move on to doing through-hole components. And you also want to do smallest to biggest. It's always easier to see the small ones before you have a bunch of big components going on. So, it's going to get a bit more solder strung out here. And then just hit it on this side. Okay. And then come over on this side. Perfect. Now, let's go ahead and do the microcontroller with ATtiny85. So, ATtiny85 will go right here, and as you can see, there's a little dot at the top, which you can see right about here, and that indicates which orientation it'll go in. So as you can see, the two dots are in the same corner, right here and right there. And then you want to do it corner by corner. So first we'll start at the top right corner, make sure it still lines up okay. Kind of line the pads, the pins, and make sure they all go down the right way. So about like that, I'd say. Looks pretty good. And then, well actually we could move it over just a tiny bit more. Like that. Perfect. And then just kind of swivel it up a bit. And then some right-handed, I just want to turn the whole thing, and then we'll get two sides at once. So we'll start down here, go to the opposite corner, and lower to the left. Same thing right there, and we'll just go ahead and do the whole side. It's okay if you get short circuits right now, because you can clean those up later. So you can see that there's a bridge across. So all you have to do to remove those, just thoroughly clean the soldering iron, and it'll wake up the solder. So just do that, and keep on getting little beads on there and just wiping them off. Go on there again, get a little bit of solder on there, and then just wipe it off. Another way, and a much faster way to do it, is to take solder wick right here and then just hover it over on the point, and then just take the soldering iron and just put it on there like that, and then it'll wick up all the excess solder and you're left with pristine pins. So we'll go and go to the other side now, do the same thing. You can see no short circuits so far. So now let's start at this corner and just hit it with a bit of solder. solder and hit it with a bit of solder. And that time, no bridging. So perfect. So now, let's go ahead and visually inspect the board. So no bridging on the micro USB port. Yeah, it's here, it's there. Good. I have the wrong micro USB port for the pad I had, but it's fine. So let's go over and check to make sure that we have connections or LEDs. Good. Good, good. Good. So all that's left now is this LDR. So now, all we have to do is put it through the hole that's labeled R1. So pull it through. Make sure it's pretty even on there. It's okay if it's not perfectly flush. So something kind of like that. And then just bend the leads over. So then you get something like this. And then just, hit it with a bit of solder. Just like that. And then you'll take flush cutters, so these guys, and then you'll just snip the leads. Careful, they might be hot after soldering. So we'll just take this lead and then give it a little bit of a trim. Perfect. So now we have a light resistor that's on there. And then if you wanted to, you can also press it down a bit more. Perfect. And that's the board. So each pad is part of the ICSP header that'd usually be on a board like this. So in-circuit serial programming. So basically, there's a SPI interface, serial programmable interface. So there's clock, master in, slave out, master out, slave in, and then reset along with ground. And then a external microcontroller will then send it a program and then program that microcontroller. So I'll go and set that up in the next clip. Here is the 18985 and it's plugged into the Arduino Nano, which has been programmed as an ISP, which will allow me to program the ATtiny without a dedicated programmer. So here is a 10 microfarad capacitor. So I have the negative side of it plugged into ground and the positive plugged into reset. I have pin 13 as the clock pin. Pin 10 is reset, ground to ground. I have the micro USB cable plugged in. Master in, slave out is plugged into pin 12, and master out, slave in is plugged into pin 11. So first step will be to make sure I have selected 85 internal 16 megahertz, port 19 is mine. Arduino's ISP is the programmer, and then burn bootloader. So this will go ahead and you can see the lights blinking. It'll burn the bootloader to the ATtiny85, and then I'll upload my sketch, and it should turn on the LEDs after it's done. And there we go. Now it all works, as you can see. So now what I can do, as you can see right here, is go and unplug from here, unplug power from the 85, and then go ahead and pull up all these, get rid of this, and then go ahead and turn on the soldering iron again, and then go ahead and desolder all of these wires. And there you have it. That is how you program the ATtiny85 using Arduino Nano. So now let's go and do a demonstration. So here is a demonstration of the board in action. So as you can see, it's gradually moving from red to blue, and then from blue to red. So very, very nice gradual transition. So it kind of breathes. And then there's also a light sensor right here. So whenever we get it bright, then the LED intensity will go up whenever it's brighter. And then when it gets darker, it'll get softer. That way it isn't blindingly bright. So as you can see here are two light up stands I've made, and there's the board that was hand soldered. So down here, you can quite plainly tell that there are LEDs down there, and they're gradually changing color from blue to red, and then back to blue. And these are the 3D printed characters. They aren't finished yet. Then inside, there are the 4 LEDs.